Question number 13. Reproduce the circuit for tripwire sensor we discussed in December. Explain in detail how it works. Make sure you explain the reason why we need pull-down resistor. This is the circuit for the tripwire. It consists of the battery, the tripwire itself, it's a little wire that's going to be broken by someone, an inverter, a resistor and a buzzer, and another resistor over here. This is how it works. The battery is 4.5 volts. That means it sends out a 1. Generally speaking, our 1s and 0s are actually voltages. So 1 is anywhere from 2 volts to 5 volts, and 0 is anything less than 0.8 volts. So the battery by itself always sends out a 1. That 1 goes through the tripwire and then goes into the inverter. The inverter turns it into a 0, and the buzzer stays silent because there is not enough voltage to turn on the buzzer. So as long as the tripwire is connected as an unbroken, the buzzer will stay silent. When the tripwire is broken, the battery is no longer connected and can no longer send a 1. So we should be getting a 0 over here, which the inverter will turn into a 1, and 2 volts or higher is more than enough to turn on the buzzer, and the buzzer will sound. The biggest problem with this setup that if we don't have this resistor over here, we are not going to get a 0 that goes into the inverter. We're going to get one of the in-between values from 0.8 to 2 volts. And those values, they completely confuse the logic gate, and it can do all sorts of strange things. So we need to make sure that this point, when the tripwire is broken, is connected to the ground somehow. But if we connect it to the ground with the straight wire, when the tripwire is closed, the straight wire will create a short circuit that will short circuit the battery. So we can't do just a straight wire. Instead, we're going to add a resistor so that we don't have a short circuit, but we are connected to the ground. So this resistor, because it helps us pull down this value from in between to 0, is called a pull down resistor.